Hello all, this is Fire. I'm going to be presenting you today an 8-bit ALU with a look ahead carry and a left and right shifter. This is going to be eventually connected to the 8-bit computer, but it's not connected now. It's just I just made the ALU and I wanted to show it to you. So I'm going to start with a demo and then I'm going to do a quick overview. I might do a detailed video later, but it's gonna be a bit too much for this one, so I'm just gonna go to a demo and then do the overview. Let's do this to force. Basically, you have these are the controllers for the ALU, and these are the controllers for the shifter. Then these are the inputs. This is input A and input B. That's how I label them. Again, none of this is actually going to stay here. None of these switches or those LEDs. This is just for this to show you here, and so I could test the ALU. The first two inputs right here for the ALU is gonna be the operation select. 0 is going to be add. 1 is going to be AND. 2 is going to be OR, and 3 is going to be nothing. There's no 3. If I ever need a 3, I would do it, but right now I really don't, so I haven't done it. Haven't done it. I'm going to start doing the add, then I'll do the AND, and then I'll do the OR. Add is a bit complicated, the AND and OR are quite simple. These are enables. When this is on, the shifter will get whatever I have here on input A, which is a 1 right now, and we're set to add. So we're actually doing 1 plus 0, which is 1. And when this is off, this is going to be 0. The same happens with B on. You get input B, which basically is doing 9 plus 16, which is 25 plus 0. So you get 25. When it's off, you get 0. These are inverters. Invert from A and invert from B. So basically you're getting all zeros on A because this is off. So if I invert it, I will get all ones. If I will enable A, have 1 all zeros, so it will be 0 all ones. It's just inverting A. Same with B. This is B, and this will be invert B. And this is just an increment, it will add 1. Supposing that I select add, it will add 1. So if we enable the first one, it will be 2. Yeah, that's 2. And let me go ahead and do the shifter, since I'm here already. And the shifter have just two inputs to the shifter, and it has 3 operations. On 0, it does nothing. If I do 1, gonna shift to the right. If I do 2, which is this one, it's going to shift to the left. And that's it. I'm gonna leave it there. Let's enable both A and B, and let's put this to 0. I'm going to do some stuff right here. Let's get this one, this one, this one. Okay, this is going to be 11, which is 1 plus 2, which is 3, plus 8, which is 11, and this is 2 plus 16, which is 18. 11 plus 8 plus 18 is going to be 29. And if you see, what I have here is 1 plus 0 plus 4, which is 5, plus 8, which is 13, plus 16, which is 29. I'm going to change this to AND and then change it to add again, so we can see how it's formed the result. I mean the speed that is done. And add. It's quite fast. Even on the last inputs that should be slower, it's actually quite fast. I'm going to actually do one that uses all the inputs over here. Let's get one, and this one, and this. So this on the top is 86. 2 plus 4, 6 plus 16 is 22. Plus 64 is 86. Actually, this actually can be done a lot faster just doing this is 10 times 2 is 20 plus 1 21 times 2 is 42 plus 1 43 times 2 is 86. If you okay, and the one on the bottom is 52. I'm just gonna do it the other way because maybe some people don't, quite a lot of people don't know that much of binary and they don't have to. So this one is 4 plus 16 is 20 plus 32 is going to be 52. Now 52 plus 86 is going to be 138. This one right here is, 138. This one is 128. This is 2, so 130. 4, 8. So 130 plus 8 is 138. I'm going to do a subtraction now because we're going to subtract with this. I actually want to do 20 minus 10. This is 4 plus 16, which is 20, and this is 8 plus 2, which is 10. If I do 20 plus 10, which is the one that is done here, it should be 30. And you have 2 plus 4, which is 6, plus 18 is 14, plus 16 is 30. What I want to do 20 minus 10, which will be a minus b. To be able to do a number minus the other one, you have to do the 2's complement, and we do the 2's complement by inverting the number and adding 1. That's why the main reason why I have these inverters. So I will do inverted of b plus 1. We should get 10, which is actually the same that we have here, 10. And I'm going to do 1 with a negative number. Let's try to do 10 minus 20, which should get negative 10. This should be the inversion of a, and plus 1. Remember, to get the negative number, we have to do 2's complement, which is this number inverted plus 1. So this will be all zeros. It will be 1, 0, 0, 1. And if we add 1 to this, it will be 1, 0. So it will be 1, 0, 1, 0, which is 10. And I guess that's it for the addition part. Let's try to do and, which is 1. And means that one input and the other. So and is just going to be true when you have one on the top and on the bottom on one side. If you see right now, we don't have any that is on both top and the bottom, and A and B. So let's do this one. Should appear there. Let's do this one. Should appear there. If I do this one, it's not going to appear because you have to be on the bottom. Let's say we take the whole of this. It's going to be low. If we invert B now, because all of these are 0, if I invert it, all of them are going to be 1. So it's going to appear all of the ones that are 1 on A. So okay, let's just finish with that. Let's do OR now. Take this out. Or it's going to be anything that is either on the top or on the bottom or on both. So if I put something here, it's going to appear. If I put something here, it's just going to stay there. So I can have a top and bottom, or I can have use on the top or use on the bottom, it doesn't matter. As long as it's on one side or the other or both, you're going to have the output here. And of course you can shift anything that you want. Let's say we can shift this one to the right, and we can shift it to the left, and we can shift it to the right, I'm just gonna briefly show you how this is made inside here, but I'm not going to go inside into many details. This is my beautiful unfinished computer. So this is just the decoder for this part is for the operations and this part is for the shifter. This is the actual part of the ALU. The inputs come inside here. These are AND gates. These are exclusive OR gates to invert it. Then I do the AND here, the OR here, and this part takes care of the addition. This is the shifter, all this part here. Now this is the same. And this part right here is going to be for the Luca high carry. Let's go more complicated. You see this stays the same. The Luca high carry gets a bit more complicated. Stays the same, slightly more complicated. Let's go all the way to the bottom. Stays the same, way more complicated. The logic behind this is just quite a simple pattern here, but I'm not gonna go into this one right here. Just wanted to show you the actual ALU. And that's it. That's all from the ALU. You have, it's actually, all this part is identical. And that right here and this one right here actually don't belong logically to the ALU. That's why I have some sort of separation. This is the decoder and that's the shifter. And if you see, all that part is the same. The Luca high carry is the one that gets more messy. So that's it. I hope you like it. And I hope I can connect it to all this soon. But first I have to do some more stuff. I just really wanted to get into the ALU, the Arithmetic and Logic Unit, because I was interested on learning how the Luca high carry worked. And I said, well, why not implement it myself if I'm gonna start learning about it? So bye, thanks for watching.